Greeting everyone and welcome to The Compute. I'm Lucy Wang. As usual, we are covering the latest developments across the world. Meta has launched Muse Spark AI, marking a significant milestone in AI advancements with robust multimodal capabilities and developer tools. In other news, Google has restructured its leadership with significant changes at DeepMind, impacting its strategic direction moving forward.
Meta's superintelligence lab publicly introduces Muse Spark, its first major AI model, alongside Muse Image and Muse Video, and announces Muse Spark 1.1 with multimodal agentic reasoning, tool use, and a public Meta Model API for developers. The public Meta Model API enables developers to build on Muse Spark, signaling a scalable, cross-app AI platform across WhatsApp, Instagram, and Messenger via the Meta Business Agent platform. This move tightens Meta's AI footprint across its apps, emphasizing an API-first, enterprise-oriented strategy, while highlighting EU and US policy discussions about privacy guardrails and responsible deployment.
As Meta transitions its focus towards advanced AI development, excitement grows in the tech community for revolutionary possibilities ahead. Attention now turns to Google's recent leadership changes, highlighting strategic shifts aimed at enhancing its AI initiatives and future directions.
DeepMind announced a leadership reshuffle in which Demis Hassabis will step down as chief executive to become chairman and Alphabet chief scientist. Kore Kavakulu will become senior vice president, and Jeff Dean is exiting to launch Discovery Loop. The move signals Google's intensified frontier model agenda and Gemini roadmap, occurring as frontier model timelines slip and talent exits continue from Google's AI research teams, aiming to stabilize leadership and sustain Gemini's momentum. This reshuffle highlights how leadership shifts influence platform strategy and talent flows, shaping the Gemini ecosystem and cross-device ambitions in a competitive AI landscape.
Following Google's leadership updates, we now turn our attention to the innovative design principles shaping Animal Kingdom TCG's gameplay. The upcoming segment examines how resource management over direct conflict influences player engagement, offering fresh dynamics in TCG design.
The Booster Pack Network episode TCG Design Theory number 10 presents Animal Kingdom TCG's non-combat design, highlighting a quest system that scales with players and centers on resource management over direct battles across scenarios and player counts. Governance layer mechanics such as mayor and assistant mayor steer negotiation, resource allocation, and quest progression in non-combat play, producing negotiation-driven pacing toward strategic area influence. Within the show's world, the shift to non-combat design signals viability for non-traditional TCGs, highlighting community-driven production and AI-assisted balance testing as validated tools for pacing without live battles.
As we pivot from discussing innovative TCG design principles, let's now turn our focus towards another groundbreaking technology. The anticipation around Apple's upcoming foldable iPhone offers a glimpse into their ambitious plans for the future of mobile devices.
Apple's foldable iPhone remains on track for a September 2026 debut, with Foxconn leading mass production prep. Trial runs occurred in April, and mass production is expected to begin in late July. The push raises demand for display driver ICs and high-end semiconductors, tightening supply chains and increasing pricing pressure. The project targets about 10 million units, supported by Samsung Display Gen 6 lines for foldable OLED panels. The launch plan signals a shift toward diversified global supply chains, with suppliers reconfiguring toward the US, Southeast Asia, and India to bolster resilience amid geopolitical frictions and export controls.
As we shift our focus, the innovation surrounding Apple's foldable iPhone indicates a significant stride in mobile technology design. We move from this coverage while we continue to monitor the situation for more material.
At GTC San Jose 2026, an NVIDIA session on simulation-first AI for healthcare robotics demonstrates workflows that fuse NVIDIA's physical AI stack, world foundation models, physics-based simulation, digital twins, and synthetic data to accelerate prototyping and reduce risk. NVIDIA's Isaac for Healthcare is highlighted as an end-to-end pipeline from data curation to digital twin testing and hardware-in-the-loop deployment for robotic surgery tasks, enabling safer, faster development cycles in clinical settings. This development points to a broader shift toward simulation-first, cross-domain healthcare robotics with digital twins and world models, while tightening FDA guidance, EU health data considerations, and ISO standards shaping governance and interoperability.
This concludes our coverage for today. We thank you for being with us and following the latest development of our stories. We invite you to subscribe to our YouTube channel, Fishstock Network, and to follow us on X at Fishstock Media to join our community. From all of us at The Compute, thank you for being with us today, and we'll see you next time.